So morning. Good morning. So can we make a start? Oops. Good morning. My name is Xiaochuan Li, and I will be your next tutor for CAE and programming. So in the next several weeks, I will be trying to help you to get familiar with a programming language called MATLAB. Can you hear me at this volume? Okay. So MATLAB has been used across industry and academics, and for example, financial sector, oil and gas sector, automotive sector, and aerospace sector. So I know some of you are already familiar with other programming languages, such as Python and C. However, it's quite important for you to understand that how MATLAB can help you through your academic career. So this is the course we have done. So in the next several weeks, I will try to help you to understand how to get started with MATLAB, how to create your own script and files, how to use different built-in MATLAB functions, and how to get familiar with different data structures. And kind of most important, how to perform different functions on vectors and matrices, because MATLAB was originally conceived to be good at matrix operations, hence the name MATLAB, which is short for Matrix Laboratory. So I will show you how to use MATLAB to visualize your data, and you can define your own functions. Also, all these relate to assignment. So the assignment will be released in the last two sessions. So in terms of assignment, I only require you to submit a MATLAB code, and there's no additional write-up, but you need to make sure that your MATLAB code is fully functional and it's readable, and do not copy from others. So this is what your assignment will be about. It involves in processing of data collected from an electrical car. So in this case, it will be a Nissan Leaf, which has already been driven by a number of DMU staff. So you will be processing the data. The data has been collected, and it is a quite large data set, involves hundreds of volumes and thousands of rows of data. So you will need to calculate, for example, speed and power consumption during a trip. So this is today's learning objectives, to get familiar with the MATLAB environment, to know how to get started, and to understand the data types and the basic mathematical operations, and to perform single calculations. You use MATLAB as an advanced calculator. So as I mentioned previously, MATLAB is short for Matrix Laboratory. It is a high-performance language. Nowadays, MATLAB has become quite a large software, which involves dozens of toolboxes. It integrates computation, visualization, and programming in an easy-to-use environment. So on these slides, I've listed some typical MATLAB applications. So obviously, you can use it for math and computation, and you can develop your own algorithm, or you can use MATLAB with different interfaces to realize real-time data acquisition. And kind of important task, you can use MATLAB to do modeling, simulation, and prototyping, especially for academics. So you can use MATLAB to visualize your data, to plot 3D plots like this, and to plot some time series figures and some bar charts. So also you can develop your own applications. You can even develop your own user interface in order to show your application to your customers or your supervisors. So this is a MATLAB environment. This will be the welcome window where MATLAB is starting. So I have to switch back to my laptop to show how we can get started with MATLAB. So this main area is called command window. You can type in some command here. Oops. And once you press enter, you will get a response from MATLAB promptly. And so, for example, I can define a variable and give it a value. So as you can see on the right-hand side here, it's called it's called workspace. It's kind of a memory of lab where all your data will be stored here. As you can see, I've already defined a variable and with a value hello. And on the left-hand side here, it's called current folder. So when you attend your lab sessions, please make sure that you adjust your current folder to your local drive. For most of you, I think it will be the H drive. So you click the Browse for Folder button, and you can navigate through to your H drive and select any folder that you want to save your files to. So on the top here, you can choose to use different functions and apps, which we'll be exploring through the course. So now switching back to the main computer. So now I want to talk about data types. There are 16 fundamental data types in MATLAB, and each of them is stored in the form of a matrix or array. So whatever it is, a local or table, a logical table, char, or cell, it will be stored in the form of a matrix or array. So I'll get started with most important ones: numerical, char, and logical. So numerical data type contains integers, for example, floating point numbers, complex numbers. Char will be mainly used for store text or letters, and logical will be the value of either 1 or 0, true or false. So let's take a look at integers and floating point numbers. So you can choose to use either signed or unsigned integers. So the difference between them is that signed integers using 1 bit of memory to store the sign, either positive or negative sign. So as a result, the maximum value of signed integers will be slightly smaller than that of an unsigned integer because you have already used up a bit of memory. So sometimes people prefer to use integers instead of floating point numbers because it is smaller in terms of memory consuming. And also you can use these two commands, intermin and intermax, to figure out the range of the values. So floating point numbers, it is a default numeric type in MATLAB. So whenever you type in some numeric value in MATLAB in your command window and assign it to a variable, so that variable will be of floating point numbers, and actually it will be of double precision. So the main difference between double and single precision is that double precision uses 64 bits of memory, and single precision using only 32 bits of memory. So similarly, you can use real min and real max to figure out the range of the value. So next, charts and characters and strings. They're mainly used for letters and text. So there are two different data types that you can choose from, either char or string. So char is basically like a sequence of characters, so it's just a numerical array, while string can be in the form of a matrix, which allows you to store much more text. So I have defined two variables here. My char is a char type, and my string is a string type. So as you can see, the two variables are exactly the same in terms of content. However, I used a single quote to define a char and used double quotes to define a string. So this example here shows that you can, a string variable can, in the form of a matrix, allows you to store more text. So another important data type, logical. So you will be using them a lot. So logical is mainly used for determining the condition or status in order for a code to run. So if something happens, then we run the code. If something does not happen, then we do not run the code. So with logical variable, you can perform different functions. For example, logical AND, logical NOT, or logical OR. You can also combine different functions. For example, you can say if condition A and condition B or condition C, then run the code. So you can also use, it's called relational operators, to determine if a variable is equal to or greater than or less than the value. So here we have two examples. So in the first example, it's used to determine whether the value of x is larger than 5. So I've already used an assignment operator to assign the value 6 to x. So 6 is larger than 5, so the outcomes will be true. In this example, it's used to determine whether the value of y is greater than or equal to 7. So I've already assigned the value 5 to y, so y is smaller than 7, so that time will be false. So once you know about different data types, you may want to know how you can deal with them. So you can perform a lot of functions. You can use basic arithmetic operators. You can add values together. You can do subtraction. You can do multiplication or division. You can choose to use exponentiation or transpose a matrix. So these are basic mathematical operators. There'll be a couple more that I'll be introducing slowly through the course. So for example, sometimes you will find a dot in front of a multiplication operator, which is called a dot operator. So the dot will change the way these fundamental operators operate, especially for matrices. So this is just a quick recap about the order of operations. So these are the order of operations that MATLAB follows. So perform calculation inside brackets, and perform exponentiation operations working from left to right, and perform multiplication and division first, and addition and subtraction second, working from left to right. So these are typical mathematical rules that MATLAB follows. So now I want to talk about variables, because variables are another core building block of almost any programming language. So for some of you, you must know how to define a variable. So for some of you, I know you already comes with a programming background. This may be easy for you, but for a lot of you who don't come with a programming background, you may find it difficult to understand the concept of a variable. So this is a way that you can define a variable in MATLAB. So you need to have a variable name. It's a user-defined name, but you need to follow certain rules to name the variable, and you need to assign with a value. So in this case, will be 19266. So in the middle here, this is an assignment operator. So this does not follow mathematical rules, which means it's not expression of equality where x equals y and y equals x. So what does that mean? I'm going to switch back to MATLAB to give you an example. So, for example, you can define a variable x and assign with a value 7 and press enter. So MATLAB gives you response. You can see I define a variable x, the value is 7. However, you cannot do something like this. So be careful with that. So this is a variable value, and I want to highlight that you do not need to specify the variable type. In other programming languages such as C, when you define a variable, you need to say what type of data it is. But in MATLAB, you automatically select the variable type for you. So this is a numerical value. So as I mentioned previously, the default data type will be double precision, a floating point number. So on these slides, is some rules in terms of naming. So very important. Syntax in MATLAB are case sensitive. So for example, items, 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 and items. These are all different MATLAB variables. So you cannot do something like when you define your own variable with the name item, the first one with a capital letter I, while later on you want to use that variable, and you choose the second one. You use a lowercase letter. That is not allowed. So you need to start your variable with a letter. You cannot start with a number. And these are some keywords that you need to be careful. You need to avoid using when defining your own variables. For example, and if, because they are reserved keywords for MATLAB for some built-in functions. So on the next page, there will be some more keywords that you should be careful with. For example, pi, this is a mathematical constant, and this means infinite. So now I want to talk about comments and punctuation. So MATLAB allows you to add comments to your codes in order to make them more readable. And also it allows you to control whether or not to print your results on the screen. So for example, in MATLAB, whenever you type in something, the results will be displayed on MATLAB automatically. This is fine with some single algorithms. However, if you're dealing with quite large algorithm, you may want to display the result for every single step. So what you can do is to put a semicolon at the end of the statement and press enter. You can see your result will not be displayed on the command window. However, you can still find the value in the workspace. So let's say if you have a code which contains 10,000 lines, so sometimes you may want to divide them into blocks and add some comments to make your code more readable. So now you can use a % sign. So the % sign allows you to put text to make comments to your codes. So all text that have % sign will be ignored by MATLAB. So with MATLAB, you can perform a lot of different mathematical functions. So what I've done is just named a few of them. I think which will be quite important for you because I know some of you are doing mechanical principle module, and which requires you to do some experiments. And now some of the experiments already requires you to use MATLAB because you will need to plot data using logarithm. So with MATLAB, you will find it's quite easy to plot data using logarithm function. These are just named a few. If you want to get a full list of mathematical functions, you can try these commands here: help lfun, help spectral, or help lmat. So I'm going to switch to MATLAB to give you an example in terms of how to use some mathematical functions. For example, I want to use sine. I just type in the name of some function and give it an input and press enter. I can also do nature logarithm. And if you want to get a full list of mathematical functions, you can try help lfun. As you can see, you can explore these functions in your free time. Oh, yeah. If you find your command window too messy, you can use CLC. No, it's not possible. So now I want to show you something that may have some value for you in terms of using MATLAB. So this figure is related to an experiment called flywheel experiment. It's related to your mechanical principles module. And during the experiment, you are required to collect some data and substitute the data into this equation. And you will need to rearrange this equation in order to calculate the moment of inertia, I. You can do it by hand. Of course, it's not a rocket science. However, I recommend you to use MATLAB because it will save you a lot of time, especially when you're dealing with larger data sets. So this is a MATLAB code that I write for this experiment. So I put in some comments to make the code more readable. So I quickly go through this and I'll give you an example later on in MATLAB. So these 3 lines here, these are some data that you will be given before the experiment. So these 2 lines are the data you are expected to collect at the end of the experiment. So I already collected the data and put it here. So I actually defined 2 matrices here. It's a 3 by 3 dimensional matrix. So this is the first column, this is the second column, this is the third column. They are separated using the same column. So similarly, I defined a 3 by 3 dimensional matrix here. So here I used the main function to calculate the average value for each column for t and n. And then this is a rearranged equation that you will need to calculate the moment of inertia, because you need to calculate the moment of inertia for 3 times. So here I use a main function again to calculate the average moment of inertia. So I'm now going to switch back to MATLAB. So I'm going to copy this code and paste into MATLAB command window. As you can see, MATLAB has already executed the code for me. So these are the results that are displayed on the screen. So this by three-dimensional matrix that I mentioned previously, T and N. And I used the main function to calculate the average value for each column. So this value is actually the average value for this column, and this element is for this column, and this element is for this column. And similarly, this element is for this column. And then I used the rearrange equation to calculate the moment of inertia for 3 times. Then I used the main function to calculate the average moment of inertia. So I want to highlight here is that you do not need to declare the data type because, as I mentioned previously, MATLAB will automatically determine the data type. In this case, this is a numerical value, so the default data type will be double precision, a floating point number. So now I want to talk about saving and load work. As I mentioned previously, all your data will be stored in the workspace. However, if you don't save your data to your local drive, for most of you it will be H drive, when you exit MATLAB, your work is gone. So in order to prevent that from happening, you can use this command. It's called save command. So it's quite easy to use. Just type save and a space, your user-defined file name, and all your data will be stored to your current folder. So I'm switching back to MATLAB. For example, I already got some variables here which I want to save. So I can use save and any user-defined name. And press enter. So as you can see, my data has been saved to my current folder, sorry. So if you want to access the data that you already saved, you can use a load function. It's called load, and the same name. So all my variables has been restored. Alternatively, you can find your pre-saved data and drag it into the workspace. It will be much easier for you to do so. So save and load, quite simple. Now I want to talk about how to get help in the command window, because MATLAB involves thousands of functions, built-in functions. So when you want to know more about a particular function, you can use a help function. So MATLAB has one of the best built-in help function among other programming languages. If you want to get more extensive help, you can use the doc command. So I'm now switching back to MATLAB. So, for example, if I want to get some help with a sine function, I can use help and space, the function name, and press enter. So MATLAB will display some basic information about this function for you. If you want to know more about this function, you can click here, a reference page for sine, and there will be a pop-up window. You can read through this detailed explanation. So what you can also do here is to select the lines and select evaluate selection. So you can see MATLAB will plot the figure for you. This is because when you click on the select evaluation, the codes will be transported back to MATLAB in order for MATLAB to execute the code for you. So you can also use the dot command. which will give you this detailed explanation straight away. So this is a web page that I recommend you to use this to learn more about MATLAB. There are thousands of tutorials and examples that can help you to better understand MATLAB in your free time. So here are some useful links that you can use to know more about MATLAB. So this first link will lead you to DMU library website. So you can find some books in relation to MATLAB. And most important one, the third one, all DMU students can download free MATLAB software and install it on your own laptop. So now I want to talk about some research projects that I've been involved in which I use MATLAB to tackle some real-world problems. So these projects I involved with a PhD student a few months ago. So we have access to the database of a large wind turbine company. So you know, wind turbines are human-designed machines, and they're subject to failures. So sometimes they want us to develop something that can help them to save money, to predict the failure. So after we get the data, we develop an algorithm in MATLAB, which enables us to predict the failures for these wind turbines very accurately, as you can see in these small figures. And all these beautiful figures are plotted using MATLAB. So another project which I involved in, like 2 or 3 years ago during my PhD, and I have access to data collected from a machine looks like this. It's called a centrifugal compressor. So I developed an algorithm using MATLAB, which enables me to predict the performance of the machine under faulty conditions. For example, in this figure, I predicted the temperature, and this figure I predicted the power consumption of this machine under faulty conditions. So it's quite a hard time. So before you go, I want to mention that there will be one lecture and one lab for each week, and I will be in charge of most of the lectures, and I will be doing some of the lab sessions as well. And my colleague Tanvir, she will be my teaching assistant. She will be helping me with some of the lab sessions. So if you do have any problem, do send me an email. So that's all for today. Thank you for your attention. I will see some of you in the lab session.
I don't know whether you're able to put me in. Sorry? I don't have my student writers.
All right.
As far as I'm
What's your name?
Max Cole. Whether you can write down.
Have your name here? Your student ID?
Yeah. Thank you.
Thank you.
I got programming with you tomorrow.
Yeah, what time? Sure. Yeah. See you tomorrow then. It will be me.
type in CMC,
Yeah.
does that actually clear all the code you put in? Like if I say x is equal to,
Yeah,
if I click CMC, does that make x not equal 10 anymore?
But MATLAB still retains your previous typing codes. You can use up arrow on this one.
Yeah.
Up arrow on keyboard to access the previous typing code.
Okay, so does it just clear it from the screen or does it actually
Just
delete
from
it?
the screen.
Okay, so it stays there. Okay. That's all.
No worries.
Cheers. Thank you.
Because that's the one thing I realised. Like, if you don't get that, if you don't have what that paintings. Yeah, I realised the sheer force if it doesn't add up to